Kia ora Year 12, here's the vectors question from the November 2015 paper. So it's got 3 parts to it, 9 marks altogether, and it's fairly straightforward but still really good to go through. So we've got 3 position vectors given to us, OA, OB and OC, and we're told that we've got a plane which is perpendicular to AB and it contains the point C. So the first thing to do is to find a vector equation for the line, which we'll call R, going through A and B. Then we're going to get the equation of the plane. And lastly, we're going to figure out where the line and the plane intersect. Okay, so starting off, the first thing we're going to do is to find the direction vector from A to B. So we just subtract the components. We get 2, -2, and 1. Right, now we know that the plane is perpendicular to AB, so looking ahead, that means that my direction vector so here's my plane, and we know it's perpendicular to AB, which means that that direction vector we just found is going to be my normal vector. So that makes life pretty easy. Now the line through A and B is going to have this equation. We need to choose either A or B. I'll choose A, so R is equal to 1, 2, 0 plus lambda times that direction vector, giving us 1 plus 2 lambda, 2 minus 2 lambda, and just lambda. Okay, so that's pretty easy for 2 marks. That's the equation of the line. Now we have to do the equation of the plane. So the normal vector is AB because the line and the plane are perpendicular. So that's 2, -2, and 1. And that means that I can write my plane in this form. 2, -2, 1 dot scalar product x, y, z is equal to some constant. 2x minus 2y plus 2 is equal to k. But we know that point C is on the plane. So the position vector of C was 1, 1, 4, from O to the origin to C was that. So C is the point version of that, 1, 1, 4. We just take those values and substitute them in. So 2 times 1 minus 2 times 1 plus 4, that's a Z there, is equal to K. So K is equal to 4, giving me the equation of the plane as 2x minus 2y plus z is equal to 4. Right, so that's another 2 marks. Now the last thing we have to do is to figure out where the line and the plane intersect. I'm going to go swooping back up to the question. Sorry about the bad noise coming. There we go. Right, so we have to find the position vector where the line and the plane intersect, and then show that from point C to that place is root 13 units long. Okay, so what's my vector equation of the line? Well, it's 1 plus 2 lambda and so on. And we know that that intersects the plane at point N. So that means we can substitute in, and we're going to solve for the value of lambda. So 2x minus 2y. So that's what we get. That gives me 9 lambda minus 2 is 4. So 9 lambda is 6, and lambda is equal to 2/3. So we now need to take this and figure out the position vector here. Right, so working that through, we get n is equal to 1 plus 2 lambda. So n is equal to this vector. Right, or you could write it with I, j, and k. Doesn't really matter. Okay, now the next thing we've got to do is to find the vector going from point C to point N. So point C had coordinates 1, 1, and 4. So we work out the distance between those two things by using Pythagoras in 3D. Okay, so that's the vector from C to N. And to find its length, this is what we do. So those numbers don't look too nice, but they clean up well. So we're going to have 9 for the denominator, 16 plus 1 plus 10, which is square root of 117 on 9, which is root 13 as required. Okay, definitely on the easy side for a vector question, I reckon. You can see that I've managed to do all 3 parts with lots and lots of talking in only 6 minutes. So a really good one for going over some basic skills.